when you say real valued functions, you are going to input real numbers, and then expected outputs are real numbers also. That's what we mean by real valued functions. So again, when I say function, we mean it real valued function. So to define a function, we need two sets. And we assume that these two sets are non-empty, meaning there is at least one element in this in each of these two sets, no? Set of real numbers. Okay? Where A and B are non-empty. A function which we are going to denote by f from set A to set B is a rule that assigns to each element let's call it x, that you can find in set a unique. So when you say unique, one and only one, element, let's call it y, that we can find in set B. So this is what we mean by a function. Now we're going to restrict our sets A and B to what? To sets of real numbers, no? So or subsets of real numbers, but the maximum set of real numbers, okay? So mathematically, this is how we write it. Mathematically, we have, or we write f is a rule that sends every element x to a unique y, where x belongs to set A and y belongs to set B. Okay, so that's what this meaning means. It's symbolically. Or we simply write f of x is equal to, y, so y is equal to f of x for simplicity. So instead of this complicated mathematical form of the definition. Now, in this simple notation for function sending x to a unique y, x here is called the independent variable. What about y? We call this dependent variable. You can think of independent variable as input variable, while dependent, you can think of this as output variable. For what reason? Because for independent variable or variable, we assign a value, meaning we input. And after inputting a value, you will expect for an output value, okay? Which is the value of the dependent variable. Okay, guys? And A here, set A, where you are going to pick the values of the independent variable or variable. So it's called the domain of F. Domain of F. Okay, guys? And then B is called the codomain of F. Now, not all elements in the codomain will be matched with every element in what? Or matched in the element in the domain of F. So, meaning A's element or the element of the domain, so each element is assigned to just one element in the codomain, but there is a possibility that some elements of B are not taken by the values of what? Of the independent variable. Okay, guys? Those values of or those elements in codomain picked by the independent variable values is called the range. So will form what we call the range of F. Okay? So we have what we call range. No? Range is a subset of the codomain. And this range is a set of all values of the independent variable. In values of the dependent, dependent. Values of the dependent variables. Okay? So again, range is a set which is a subset of codomain because not all elements of the codomain are picked by the elements of the domain. Okay? But every element of the domain must be what? Must have a partner with the element in the set B. No? And those elements in the codomain that are picked by the independent variable values will form what we call range. Is that clear, guys? So there are many ways by which you can express functions, no? So you can have it by mapping diagram. Then we have what we call ordered pair, set of ordered pairs, and then also by tables, by equations, no? So ways of writing or expressing functions, no? So again, number one, we have what we call mapping diagram. So through mapping diagram, we have, let's say, this set represented by this closed figure, and I'm going to have elements inside. So let's say the elements inside are the following dots, and they have corresponding values. For instance, -5, -3, 2, 0, 1, 4. And there is another set. Let's say this is the other set. And this set contains also numbers, no? Represented. Let's have the dots representing the numbers. Okay, so let's say this is -9, -5, -4, 0, 1, 2, 7, 6, 7, let's say 10, 12. Okay, now let's call the yellow set A, set A, and this blue one set B. So F is going to send every element of A to what? To some elements of what? Of B. Because not all elements of B all the time taken. No? So F is a rule assigning every element here. But how is the assigning being done? So for every element in A, you are going to assign a unique element coming from B. No? So for instance, I'm going to assign this to -9. 3, I'm going to assign it to -4. Let's say this 2 is assigned to 7. And then 0 is assigned to 0. And then 1 is assigned to, let's say, 7 again. And then 4 is assigned to 12. So what do you notice? Every element in A, how many partners in B? One and only one. -5 is just partner to -9. 3, -3, just to -4. 2, well, how many partners? Just one also, 7. 0, how many partners? Just 0 only. 1, just 7 only. 4, just 12 only. Okay? So this is a function. Here, we say that f is a function. Is that clear, guys? Yan.
Yes, sir.
Now, if I have, for instance, a mapping diagram like this, let's say this is my mapping diagram. Let's call this A, and then this is B, no? Let's now choose Y, B, and let's say G is the name of my function. Not all the time F is the name. Huh? G is going to send every element here, every element. So let's say 5, -2, 4, 0. And I have 1, 2, 3, 4 also, no? Yan. And let's say 6, 2, 0, -8. Let's say I assign 5 to +2. I assign 5 to another value, -8. 2 is assigned to, let's say, 6. 4 is assigned to 0. And then 4 is assigned to, let's say, -1. What do you notice, guys? There is a number or there is an element in A having how many partners? Guys, how many partners?
Two po.
2, sir.
6
2 po.
and -8. No? So meaning, we have this notation for matching, no? Or for mapping. So it looks like greater than, no? I mean, less than, right? Parang it's like less than, no? If there is a symbol like this that you see in the mapping, so it means it's not a function. Okay? But if you have a symbol like greater than this, or like parallel, or something like this, but they don't intersect, so it means function. Okay, guys? But if you have like this, just one of like this, like 5, like going to be to 6 and -8, so it looks like less than, right, guys? Get it, guys? So
Yes
it's
po.
not a function. So we say G is not a function, meaning it is simply a relation. G is not a function. Take note that function is a relation, but not all relations are functions. Clear now, guys? You can also express um, functions as a set of real numbers. So set of real numbers. So function as a set of real numbers. Now we say real numbers because we will be limiting our functions to involve real numbers only, okay? Although, in general, functions can have elements that are not just real numbers, can be complex numbers, can be characters, like can be names, locations, and so on. We can also define function as a set of real numbers, no? So, again, function, I can define it also as a set of ordered pairs. Actually, not actual set of real numbers, but set of ordered pairs, set of ordered. Let me correct that. Set of ordered pairs of real numbers. I got a mistake in stating as a set of real numbers. Okay, set of ordered pairs of real numbers. So again, a function can also be defined as a set of ordered pairs of real numbers of the form xy such that no two distinct components no two distinct ordered pairs have the same first coordinate. Same first coordinate. Okay, guys? So meaning for 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 any two given distinct ordered pairs in the set, the value of x should not be what? Repeated. Okay? Now, for instance, if I have f as the name of my function and having the following elements inside the set, 2, 4, let's say 3, 9, negative 3, 6. Now, so this f defines a function. Okay, guys? Why is it that this defines a function? If you're going to look at f, uh, two distinct order pairs like 2, 4, 3, 9, they are distinct. Do they have the same first component? No. Take another 2. Do they have the same first component? No. This 2. Do they have the same first component? No. Is that clear, guys? What about this? Negative 1, 3, positive 4, 3, 5, 1, 6, 7. Yan. How many ordered pairs inside? 1, 2, 3, 4. So, any pair of ordered pairs taken here, they don't have what? Same first coordinate, right, guys? So, this is a, a function, or it defines a function. Let's say my h is the name of my function, and I have 2, 5, and then negative 3, 6, I have 2, 7, then 3, 1. Now, does this define a function, guys? What do you think?
No, sir.
Not defining a function. Why is it that this does not define a function? Because of what? This ordered pairs, no? So they have the same first element here. Is that clear, guys? So they are distinct, but notice they have the same first coordinate. Okay? You can also think of a function as what? As a machine. Number 3, you can think of a function as a machine. So as a machine, we have, for instance, my machine is given by this with inlet or opening here, opening to accept materials, no? Or input, and then we will be calling this machine as what? As machine F, machine F, and then there is another opening which is called outlet. So let's call this outlet. Yeah. Okay. Now, a number will enter the machine, F will process it, and then there will be a finished product, and that is the output. Call it Y. Okay, guys? Or that is equal to F of X. That Y is F of X. F is going to work on X, and that is actually the Y, no? In simplest form. So, but you can have it also F of X, and let's call that F of XY after processing X. Is that clear, guys? So that's how a function looks like as a machine. We can have also equation as what? I mean, function as what? Function in terms of equation, no? Function as an equation, which is normally encountered in what? In the study of functions in calculus. So as an equation, we write y yan, equals f of x. Okay, guys? And I explained to you what this notation means already. Okay? So for instance, I can have f of x. This is my y. And that is equal to, for instance, 4x minus 3. I can have g of x equals 5x squared minus 4x plus 8. No? H of x is equal to 4 minus x all over x plus 4. And then I can have big F of x is equal to square root of 4 minus x squared, and many more, of course, no? Like in your trigo, you have, let's say, big G of x is equal, for instance, to sine x plus 4. Exponential functions like, let's say, j of x is equal to e to the x plus 2 to the x minus 1. And then I can have a logarithmic function like logarithm of x minus 4 to the base 3. Okay? So these are functions in terms of equations. Um, there are, let us talk about this now. So let us consider By the way, there is another one, number 6. So we have function. Of course, these are not the only ways, no? These are some common ways of writing or expressing functions. You can also express functions in terms of graphs. So function as a graph, no? Yan. Yan. So again, function as a graph. So for instance, if we have this one, let's say this is my x-axis, I mean y-axis. And then let me have my my x-axis. Let's call that the x-axis. Yeah. I can have a graph like this. No? Yeah. This is the graph of a function, a sample one. Okay, guys? So we call this, let's say, y as a function of x. Normally, this is a graph of a polynomial function. So we're going to focus on this function as what? As an equation. Consider a function given by y equals f of x. Again, here we call f function name. X input or independent variable. What about y? Y output or what, guys? Or dependent and variable. Okay? And in this notation, there are two sets involved, no? Important sets. We call these set components, no? Set components of any function. What are they? Domain and range. Okay? So number one, we have domain. Domain is a set of all values of the independent variable or variable. No? An independent variable, meaning set of all values that we assign to the independent variable or variable. No? So number two, we have what we call range. So range is a set of all values of the independent sorry, supposed to be dependent. Let me correct that. Dependent variable. Okay, guys? And when we say independent variable, it means what, guys? It is a variable whose value is being assigned. Okay, guys? While dependent variable it is a variable whose value depends on value assigned to the independent variable. Okay, guys? So meaning for the choice of x values, no? So how to determine the domain and range of functions, no? Although there are functions, hard to determine the range, but of course you will not be given such functions if to asking for the range if not manageable, no? Okay, guys? So finding domain and range. Let's say we're asked to find the domain of the given function. Let me include the graph, no? Sketch the graph. You sketch the graph. And determine the domain and range of the given function. You still alive, guys? Guys.
Yes, sir.
Number one, let's say I have f of x and it is equal to -3. We call this constant function. Why is it a constant function, guys? Because the value of the function is constant, always -3. For every input, whatever input you have, so the value of the function is always -3. So it's a constant function. So if you're going to draw the graph of this, the graph is a horizontal line passing through -3 along the y-axis, no? 1, 2, 3, 4. Let's say this is -4. This is -2. So this is the graph, horizontal line passing through yan, y equals -3. Is that clear, guys? So this is f of x equals -3. So if you're going to look at the graph, what is the domain of f, guys? What is the domain? Notice that we have all the x values, no, along the x-axis. So it means the domain is the set of all real numbers. In interval notation, so you have to recall interval notation. I'm not going to discuss this anymore. If you have forgotten this, you try to YouTube it or Google, no? How the different forms of interval notations. We have infinite and finite interval. So there is what we call open, close, half open, half closed, no? Guys, this is an example of an infinite interval, no? Okay, guys? What about the range? Anyone?
-3 lang po, sir.
So there is only one element, no? In the range, -3. So that's how you write it because it is a form, it is a set. So we write it this way, no? So that's the range, the value of y. Or you can say set of all y's such that y is equal to -3. So let's have number 2. If I have, let's say, g of x, this is my function, and it is equal to 4 minus, let's say, 3x. So we call this linear function. Okay? Linear function is always a what? A function, no? This form. So it takes the form f of x equals mx plus b, where m is not equal to 0. If m is 0, it becomes what? A constant function. Here m is -3, the slope. We call that the slope. This is slope. Yan. Slope. The b is the y-intercept. Okay, guys? So that's the y-intercept. To be able to draw the graph of this, we're going to prepare a table of values. Actually, two values of x enough to get two ordered pairs, no? The graph of a linear function is a straight line, slant. So when x is, for instance, 0, what's the value of y or g of x? G of 0 is 4, no? Okay, guys? Is that clear, children? If x is, let's say, 2, what's the value? 4 minus 6, -2. Am I correct, guys? So let's now draw the y-axis. So this is my y-axis. My x-axis, we have this. Let's have 1, 2, 3, 4. And then I have here 1, 2, 3. I think I need to move this down. Okay. Uh-huh. So we have 0, 4. Where is 0, 4, guys? So somewhere here, no? 0, 4, 2, -2. So we have here, let me extend this. 1, 2. So 2, -2. Am I correct, guys? Guys?
Yes,
Yes po,
sir.
sir.
Okay, so I'm going to connect this. Let me draw a line. I mean, okay. Let me make it straight. Oh, you cannot make it straight. Okay. So hey, there it goes. Okay, guys. So that's how the graph looks like. So clear, guys. So this is y equals 4 minus 3x, or g of x equals 4 minus 3x. So what about the domain? Anyone? Look at the graph. So the domain is also the set of all real numbers, right? What
Yes
about
po.
the range?
Set of all real numbers din po, sir.
Set of all real numbers. You can have interval notation or this notation for the set of real numbers. Number 3. So we have f of x is equal to x squared minus 4x plus 5. So we call this quadratic function. Do you know the standard form for a quadratic function, guys? So that we will be able to get the vertex because it has a vertex. Now, a quadratic function takes the form ax squared plus bx plus c, where a is not equal to 0. So this is our quadratic function. Okay? So if you're going to let this as y, and then complete the square here, x squared minus 4x, to make it a perfect square trinomial. So I need 5, so plus 1, no? 4 plus 1 is 5. Okay, guys? And this is factorable into x minus 2 quantity squared plus 1. So it means the vertex is at 2. So where this is x minus 2, so h here is 2. So this takes the form y equals a x minus h quantity squared plus k. Okay? So if minus here, plus here. If plus here, minus here. And then this is the k. So it means the vertex is at 2, 1. And the graph will separate from that point, no? And also, the graph opens upward. You still remember, guys, in your pre-calculus, opens upward. Okay? So let's have, and let's have some points, no? You're going to assign a value, one value to the left of the vertex and one value to the right of the vertex. So to the left, let's say 1, and then to the right, so let's say 3. What are the corresponding values, guys? 1 minus 4 plus 5, positive 2 here. So 9 minus 12 plus 5, still positive 2, no? Okay? So I'm now going to draw. Okay, so let me make it straight. I can straight it, make it, yeah. Oh, sorry. It did not. Yeah. And then I'm going to copy, rotate. Okay. So vertex at 2, 1, and then we have 1, 2, 1, 2, 3, 4. And then here 1, 2, 3, 4. Okay, guys? Vertex is where, children? 2, 1. Somewhere here. Am I correct, guys? Guys.
Yes po, sir.
Then,
Yes, sir. Yes, sir.
let me make it bigger. So, thicker. So, we have 1, 2, 1, 2. And then 3, same, no? Same height. So, then we're going to draw now. When x is 0, we have 5. So, somewhere there. So, the graph goes from here, going upward. Okay, guys? Oh, let me... It's not nice. I can't hit it well. Okay. So this is just an approximate graph, of course, children. That's the graph of that parabola. So this is the vertex. So as you see, the graph goes from going to the left and going to the right without end, no? So what do you think the domain? Set of all real numbers. Because quadratic is a polynomial function, if it is a polynomial function, the the domain is always the set of all real numbers. Linear function, constant function, they belong to the family of polynomial functions. What about the range, guys? What do you think? Look at the graph. It starts from the vertex going upward. So what's the value of the y in the vertex? 1, no? Starting from 1, going upward. Is that clear, children? So that's the range. So what about if I have this number 3? F of x is equal to negative 2 x squared minus 12x plus, let's say, I will have here negative. Let me check. I want it to be a nice one. This is negative 18. I want it plus, let's say, 15. So this is supposed to be negative 3. So this is what I want. Okay, guys? Yan. So again, this is a quadratic. Notice that a here is -2. So this is the coefficient of quadratic. So automatic, this opens what? Opens downward. Okay, guys? So let that by equal to y, and this is factoring out -2 from the first two terms. We get x squared plus 6x, okay? Then minus 3. Then let's make it a perfect square trinomial by adding inside 9. Half the coefficient is square it. Half of 6 is what? 3 square it 9. So actually, what I added is -18. But I want it to be -3, so plus 15. Sorry. I want this to be perfect, so this is plus 15. And I want it plus 15. So that the vertex is just small. Again, -18 to what? To be positive 15. So I add what? And this is negative, no? Sorry. Negative. So I have to add 3, no? Am I right now, guys? -18 plus 3, 15, no? Negative. So it goes back to the original. So this is equal to what? To what? To -2 multiplied by x plus 3, quantity squared plus 3. So what's the vertex this time? -3, +3. And this opens, as I mentioned, opens downward, no? Guys? Yan. So, how do we draw the graph? Let's have this, make it straight into shape. Then let me copy that. And then rotate. Vertex is where? At -3, 3. I think we don't have much space here. Let's have it here. So, if you prepare other points on the parabola, this is parabola, no, guys? One value to the left of -3, -4, and one value to the right, positive or negative, one value. Positive, or you can have -2, one close to -3. When x is -4, -2 times 16 minus 12 times -4 minus 15. So that is positive 1. Could you please check, guys? -2 times 16, it will become plus 12 times 4 minus 15. Okay? And then I think this is also 1. -2 times 4 plus 24 minus 15. Okay, children? Is that clear, guys?
Yes, sir.
So we have, what are the points, guys? -4, 1, no? I'm going to move here. And then it goes down. Okay. Y, and this is x. -1, -2, -3, -4, -5, -6. So this is -6, -4, -2. This is 1, 2, 1, 2, 1, Let's have 1, 2, 3, 4. Okay. -4. -2. This is 2. Oh, what are the points again? Vertex -3, 3. Oh, I think I need to move this down more. I need 3. I need to move this down. Sorry. Everything this here. I need one more here. Let me check. Is that enough? Oh, I think enough. So -3, and this is now 3, no? Let me correct this. This is 1, 2. Guys, this is 3, 3, 3, right? Somewhere here. Then -4, 1, somewhere here. And then -2, 1 also. Okay, children? Guys, so going down, just approximate the intersection along the y-axis. I mean along the x-axis. Just approximate. Okay, guys? Yan. So something like this. So this is the vertex. Okay. What do you think the domain again? Because it is a quadratic automatic, the domain is the set of all real numbers. Or in interval notation, we have this. What about the range, guys? The range is -infinity to what, guys?
To 3 po, sir.
To 3, no? To 3, yan. Or you can have it set of all y such that y is to the left of 3 or equal to 3. Okay? Is this clear, guys? What
Yes,
about number
yes, sir.
4? If I have my f of x is equal to x all over x minus 3. Okay? So how to draw the graph of irrational function? To draw the graph of irrational function, we're going to get the asymptote, no? There is what we call vertical asymptote for this, and that is x equals 3. Vertical asymptote. So it is where the denominator will be what? Will be 0, no? And then this is a line, no? Vertical line. We assign value to the left of 3 and to the right of 3. I think 2 values to the left, 2 values to the right, enough. So when x is, let's say, 1, 2 to the right, 4, 5. When x is 1, what do you think the value? 1 divided by -2. So that is -1/2. No? 2 divided by 2 minus 3. 2 divided by 2 minus 3, that is -2. And then 4 divided by 4 minus 3 is 1. So, so this is, am I right, guys? When x is 4,
4, sir. 4 po.
tama ba ako?
4 po, sir.
The 1 divided by, I'm checking the first one. This I think is 1 divided by 1 minus 3. Negative 1 half. 2 divided by 2 minus 3 is negative 2. 4 divided by 4 minus 3. Positive 4, right? 5
Yes, sir.
Yes, sir.
Positive.
Yes, sir. 4 po.
divided by 5 minus 3. Is it 5 halves? No?
Yes, sir. Yes, sir.
Okay. So we now draw again. Well, let's make it straight. Copy. Then rotate. Our vertical asymptote is at where? X equals 3, no? Yeah. So let's say this is 1, 2, 3. When x is 1, 1/2, negative. So maximum for y is, that I have is 4, no? 1, 2, 3, 4. Let's have this. Okay. Then here 4, 1, 2, 3, 4, 5. Let me extend this here. Okay. When x is 1, negative 1/2. If this is 1, this is negative 1/2 somewhere here. This is my point. Right, guys? Approximate only, of course. 2, negative 2. I have here 2. Negative 2. And then what about 4? 4, no? Here, 4. 5, 2.5. 5, 2.5. This is 2.5. Approximate only, guys. I'm just approximating. This is my asymptote. X equals 3, vertical asymptote. Okay, children? Were you able to meet this term when you were in Gen Math?
Yes, sir. Yes, sir po.
Yeah, something like this. So the graph is asymptotic. Going here, asymptotic to this pink, no? Asymptotic to that pink. But there is what we call possible horizontal asymptote. Now, to determine the horizontal asymptote, we let that y equals x over x minus 3. And then you solve for x in terms of y. So xy minus 3y equals x. We multiply by x minus 3 each side. Solving for x, we have xy minus x is equal to 3y. Factoring out x, y minus 1 equals 3y. So what is x, guys? 3y all over y minus 1. Am I right? So I think the horizontal asymptote is y equals 1. And it is where the denominator will be 0 here when y is 1. So this is horizontal asymptote. So the graph will approach this, na? Okay, so going to that, approaching. So when y is 0, x is 0, it will pass through this point. No? And then asymptotic to the pink. But that's it. That's how it looks like. Approximately. That's the graph. And if you're going to look at the domain is where the denominator is always not 0, no? So meaning set of all x such that x is not equal to 3, no? Because when x is 3, it will become undefined. Or we can write this negative infinity to 3, but of course, parentheses there, meaning not included, union with greater than 3 to positive infinity. Okay, guys? What about the range? Children, what do you think the range? Set of all y such that y is not equal to 1, no? Or that is negative infinity to less than 1, union with greater than 1 to positive infinity. Any question with this, children? Guys?
None po, sir.
What about if I have g of x is equal to square root of 4 minus x? Okay, guys? So this is root function, no? Actually, this is half of the parabola, upper part of the parabola, with endpoint at x equals 4, and when x is 4, this is 0. Okay, guys? So, and then going to to what? So it goes to the left. It goes to the left. Goes to left. Starting from 4, 0. Well, let's do that. I think I need this graph. Let me copy this. Going to the left, and then this part. Uh-huh. Okay, I will erase this part and that part. Okay. By the way, let's label this 1, 2, 3, 4, and this is 1, 2, 3, 4, negative 2. This is negative 2, 2, 4, 2, 4. Am I right? Oh, let's prepare values of x, then solve for the corresponding values of y. So we have 4, 0 already, no? When x is 4, y here is 0. What else? When x is 0, what is the value of square root of 4? 2, no? Yeah. So we have 4, 0, and then 0, 2. So it goes to the, approximately it's like this. Okay. Then it goes upward. Gradual, no? It gradually goes upward. So this, the lower part is like this, no? Reflection of this. But we want only the upper part because this is positive radical. Clear, guys? So that's the graph. Half of the parabola. What's the domain, children? Guys, what do you think? So the domain, we
4,
want
sir.
4 minus
Only
x to be greater than or equal to 0, no? So negative x is greater than or equal to negative 4. Therefore, x is less than or equal to 4. So Negative infinity to 4. Am I right?
Yes, sir. Yes,
What
sir.
about the range? 0 going up, no? Gradual. It goes upward without end, but gradual. Okay? What about if I have number 6? F of x is equal to negative square root of 25 minus x squared. So this is lower part of a circle, lower part of a circle. Of radius what? Of radius, what radius guys? Radius 5. If you still remember, I think I need to copy this and this so that I'm not going to, let's have it here. Lower part, no? Lower part. Okay. And then we count 5 units. So let's say this is 5. I want this to be 5. And then here, negative 5. Okay, guys? And then here, negative 5 too. So the graph is lower part of the circle passing through this point. So if you can have values, no? If x is negative 5, we have 0. If x is positive 5, we have 0, the y. If x is 0, 25 minus 0, so that is 25, square root is 5, so negative 5. Okay, guys? So when x is 0, so here, so this is the circle, the lower part of the circle. It's hard to draw that, no? Because it's a circle, and of course, I can't hit it. Let me revise this part. It's supposed to be semicircle, huh? But unfortunately, I can't make it perfect. Okay, guys? Get it, children? What's the domain, guys? What do you think?
Negative 5 to 5 po, sir.
So the domain is from negative 5 to 5, no? Close interval, negative 5 to 5. What about the range, children?
Negative
Range.
5 to 0 po.
Negative 5 to 0, no? Yan. Clear, guys? What about piecewise functions? No? Are you familiar with piecewise functions, children?
Yes, sir.
Piecewise defined functions. Defined, or sometimes called split functions. So how do we define a piecewise defined function, children? It is a special function defined by what? By more than what? More than one expression. More than one expression. At different parts of its domain. Meaning the domain is what? Divided into subdomains, right? Am I correct, children? Yeah. So that's what we mean by piecewise defined function. It's a special function defined by more than one expression at different parts of its domain. Examples, we have the following. So number one, so f of x is equal to 2 if x is, let's say, less than 1, and it is equal to negative 3 if x is greater than positive 2. Okay, guys? So how does the graph looks like, children?
Splits in two, sir.
So let's draw. So if x is equal to 2, I mean if the value of f is 2, so that is y equals to, no, horizontal. So we have y equals 2, but we want it for x less than 1. And then the other one, y equals negative 3, but we want x to be greater than 2. So let's have, I think I need to put this up a little bit. 1, 2, 3. So this is y. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Negative 1, negative 2, negative 3. Okay. So we draw a horizontal line passing through y equals 2. Let's have a blue. Let's make this a straight line. Shape into shape. Oh, it fails. One more time, into shape. Come on. Okay. Sometimes the software or the Microsoft finds it difficult to draw the graph. We start with what? With greater than 1, no? When x is greater. So meaning, there is a hole when x is 1. When x is 1, there is a hole. Am I correct, children? Do you distinguish the hole, guys?
Yes, sir.
Guys?
Kasi hindi po included yung 1, sir. Kasi less than.
Yes, very good.
Great.
There is another whole, right? When x is what? 2, no? When x is 2. By the way, this is not a function. It should be, I will change, no? This is not a function. I will change the restriction. Okay. I got a mistake. The restriction is correct. This is supposed to be going to the left. No, guys? Let us now move this to the this graph. Let's move this move it here. When x is greater than 2, somewhere here. Okay, children? So that is the one that is going to the right. Okay. This is supposed to be whole. So sa 3, no? Negative 3, supposed to be here. Let me move that later. Okay, let me move a little this here. One more, I think. And then this part going to be here. Am I now right, guys? Boys.
Yes po, sir.
And this one is supposed to be going to the left. Yan. Okay? Less than 1, greater than 2. Got it, guys? Oh, what do you think is the domain, children? Guys, what do you think is the domain? Guys, negative infinity to less than 1, right? Union with greater than 2 to positive infinity. So that's the domain. What about the range, children?
2 and negative 3, sir.
So the set containing 2 and negative 3 only, no? Okay. So that's the domain. Okay, guys? You can write set of all x such that x is equal to negative 3, positive 2. Okay? Number 2. G of x is equal to so I have x plus 1 if x is less than negative 1 and it is equal to 0 if x is equal to 0 and it is equal to negative x if x is greater than or equal to, I mean greater than 0. Okay, guys? So there are 3 expressions defining g here. The first one, g of x is equal to x plus 1. So x plus 1 is the expression defining g if x is less than negative 1. And it is equal to 0 when x is 0. Negative x when x is greater than 0. Okay? So let's have the first one, y equals x plus 1. That is when x is to the left of negative 1. So we're going to assign values to x, solve for y, no? When x is negative 1, so this is 0, right? If x is negative 2, what's the value? Negative 1. Am I correct, guys?
Yes, sir. Yes, sir.
But take note,
Yes,
at
sir.
negative 1, 0, it's supposed to be whole, huh? Although I assign negative 1 2x, then I got 0, but it is supposed to be whole. Got it, guys? So the other one, y equals negative x. You can easily draw the graph of g of x equals 0 when x is 0. That is just a point. This is when x is greater than 0. So let's now assign values. When x is 0, y is 0. When x is 1, y is negative 1. Okay? Yan. So let's now finalize the graph of this piecewise function. I need this 1, 2. Let me copy this. Yan. Okay. I think need here so that it's not congested there. So this is our y axis, x axis. 1, 2. 1, 2. Let's have up to 3. Negative 3, negative 4. Negative 4, negative 2. 1, 2, 3. This is 3, 1. X-axis, negative 1. I mean, y-axis, positive 1, positive 2, negative 2, then positive 2 here. Okay, so now let's have our first point, but I think it's a whole, no? Whole where negative 1, 0, negative 1, whole. It is a whole. Okay, guys? Now, next, negative 2, negative 1, negative 2, negative 1. Somewhere here. So let me draw a straight line. And I want this to be really straight. So I change this to ink to shape. Okay, that's better. Got it, guys? Going to the left, no? Yan. And it goes downward without end, and to the left without end. But it stops right here, no? And then when x is 0, y is 0. When x is 0, y is 0. So somewhere here. Correct, guys? What about when x is 0 here? It starts here, but when x is 1, 1, negative 1. Okay. So it so happens that this negative x connects with 0, 0, right? Am I correct, children?
Yes, sir. Yes, sir.
So it's not anymore whole sa 0, 0, no? Because it is saved by the 0, 0, which connects to negative x. While the other one has no connection, no? With 0, 0, this x plus 1. Okay, guys? What do you think is the range, children, and the domain? Domain first. Domain, negative infinity to negative 1, but that's not included, no? Union with, we include 0, right? To
Yes,
positive
sir.
infinity. What about the range? Guys, going to be negative infinity to, do we include 0, children? Do we include?
Yes, sir.
because there is a point there, no? Although open here, but there is a point accommodating y equals 0. So that's the range. Any question, guys, with the piecewise? Number 3, f of x is equal to it is x minus 2 if x is less than 2, it is square root of 4 minus x squared if x is between let me have it 0 because I want to 0, and it is between 0 and 2, including 0, when x is between 0 and 2, no, including 0. So if f of x equals square root of 4 minus x squared, so that is if x is this, between this. And it is, let's say, x squared minus 1 minus 2. If x is greater than or equal to 2. Okay, so let's have this. So there are 3 sub-functions, no? X minus 2 if x is what? To the left of 0. Well, let's assign values. Assigning does not mean the ordered pair is included, ha? So starting sa 0, but of course not included in that case. And then negative 1, we have negative 3. What about when y is equal to square root of 4 minus x squared? This is upper circle, no? With radius what? Radius 2. So meaning negative starting from x equals 0 to what? To 2, no? And then when x is 0, what's the y value? 2. When x is 2, what's the y value? 0. Got it, guys? And then the last one, it's a parabola opening upward. Y is equal to x squared minus 2. What's the vertex, guys? Vertex of this is 0, negative 2, right? This is the k. So 0, the h. Opens upward. We assign value to x and y to the left ng 0, but we are interested only to the right, no? To the right of 2, I mean. But the vertex is here, but it so happens that the vertex is not part, no, of this because you want it greater than 2. When x is 2, what is the y value, guys? 4, it is equal to 2. When x is 3, 9 minus 2, 7. Am I right, guys?
Yes, sir.
Yes po.
There are what we call special functions, guys. Other special functions. So number 1, we have what we call absolute value function. Are you familiar with absolute value function, children? Absolute value function is actually a piecewise function. Do you agree with that, guys? Children, it takes the form f of x or y equals. So this is the basic form, no? But you can manipulate this x to come up with a more complicated absolute value function. What's the domain of this, guys? What's the domain? The set of all real numbers. What about the range? Non-negative real numbers. So meaning from 0 going to positive infinity. Okay, children? This is defined as what? By a piecewise function. No? It is negative x if x is what? Less than 0. It is x if x is greater than or equal to 0. Equality can be in the less than or can be in the greater than. It doesn't matter. No? Because if you have x is 0, negative 0 is still 0. Okay? So that's how we define absolute value. In terms of radical, we can also define absolute value as square root of x squared. Get, guys? Not just x. The square root of x squared is not simply x. It is the absolute value of x. If your x can be any real number. Okay, children? It has a V shape. Has a V shape. V shape. So meaning it has a vertex. Vertex. If this is the case, so minimum at the vertex, no? Minimum value of the absolute value of f is at V, no? At the vertex. Okay, guys? How does the graph looks like, children? Again, the graph looks like a V shape, no? With vertex where at the origin, no? Get it, guys? Let's have 1, 2. 1. So this is the shape. It's like voltage 5, no? Voltage 5. Vertex here, when x is 0, f of x is 0 or y is 0. When x is 1, so we substitute here. Y is 1. Also, no? When x is 2, y is 2 also. So we have here and then here, no? So we draw this. Let me convert this to incline, a straight line, into shape. Oh, it fails. Yan. And okay, so going here. So it's like ball test 5. Yan. This is the favorite function of ball test 5, the legacy. I'm excited with that. When will it be shown? Not yet finalized, no? Have you heard that? Ball test 5 legacy. So we have here, when x is negative 1, y is what? 1 also, right? So the point is somewhere here. Let me check here. Okay. Is that okay now? That's it. Is that clear, children? Guys?
Yes, sir.
2 to -1. What will be the effect if I'm going to negate the absolute value? If I will have, let's say, negative absolute value of x, guys, what if I have f of x equals negative absolute value of x? What will happen to the graph, children?
Pababa
It will
yata,
be,
sir.
it will be flipped, na? Am I right? So the effect is just flipping, no? Okay, children?
Yes po, sir.
So let me group this. No? I mean this, and this. I and I'm going to group and then flip it. Group. I'm going to flip how to flip this. And is it not grouped to this? And flip, rotate. Yan. Then I will be transferring my x-axis here. Correct, guys? Then of course I need to remove this. So that's how it looks like. Get it, children?
Yes, sir.
Oh, what's now the domain for this? Is still the set of all real numbers. But what about the range? Negative infinity to 0, right? Okay. Next meeting we'll have some more, and then, or I might have a recordings. So I will just send it so that we can start with the limits, because we're a little bit late, guys. Actually, we're not supposed to discuss this because these were already topics in your senior high. But unfortunately, some of you might not be from STEM, no? So let's say from other strand. So they did not have much about functions, perhaps. Okay, guys? Okay. Any question before I leave, children?
None po.
Okay.
Like for me, sir, all is clear po.